Welcome back, everybody. We are still on section R.3. Today we're going to talk about some special products of polynomials. So there's two formats that we can use to shortcut our multiplication. The product of the sum and difference of two terms is the difference of squares. So if you have a format of two terms that are exactly the same, one's adding and one's subtracting, and it doesn't matter the order of this, it can be subtracting here and adding here, then you can simplify the process of multiplying by just saying x times x, y times y. If you have x plus y with a square on the outside, remember we can never distribute a square. There's always going to be middle terms in there. And so these are the formats that you can use. It'll always work, always give you an answer. This is not something that you have to do. But if it helps you kind of shorten things and you like shortcuts, then maybe this is the route that you want to go. Looking at example A, I have 3p and 3p, and then 11 and 11 plus minus. That means this is going to be a difference of squares formula. So we can do 3p times 3p, which is 9p squared. 11 times 11, which is 121. And then subtraction. Remember, a positive times a negative is always a negative. And so this would be my answer to that. Letter B, again, 5m cubed, 5n cubed, 3, 3, a plus and a minus. So this is again going to be a difference of squares. 5m cubed times 5m cubed is 25m to the 6th. 3 times 3 is 9, and it'll be subtraction because of a positive times a negative. And that would be my final answer. Letter C, 9k, 9k, 11r cubed, 11r cubed, minus plus. Exactly the same, different signs. So 9k times 9k is 81k squared. 11r cubed times 11r cubed is 121r to the 6th. And then subtraction. So those are using the shortcuts for difference of squares. For letter D, we have a square on the outside. So this is going to be the square of a binomial. If I'm using the shortcut that's listed, it says first square the first term. So 2m times 2m is 4m squared. Whatever sign this is goes next. And it's 2 times x times y. So 2m times 5 is 10m. And then plus, square the back, 5 squared is 25. Finish this by doing the 2 times 10m in the middle, and 4m squared plus 20m plus 25 would be our final answer, using the shortcut given at the first part of this lesson. We do the same thing for letter E. For letter E, we have a square on the outside. So squaring the 3x, that's 9x squared. Whatever this sign is what we follow with 2 times. Multiply these two together. So 7 times 3 is 21, xy to the 4th. And then we square the 7y to the 4th. So plus 49y to the 8th, because it's 4 times 2. Finish with doing the math in the middle there. We have 9x squared. Negative 2 times 21 is negative 42. Xy to the 4th plus 49 y to the 8th. And that would be our final answer. Now remember, you do not have to use these shortcuts. If you don't want to use the shortcuts, it is totally fine. Instead, for example, what I would do for letter E is I would write that as 3x minus 7y times 3x minus 7y. That's what the square means. You write it twice. Then you can do FOIL, you can use distribute, you can use that Punnett square method, whatever method you like to do that multiplication. Multiplying more complicated polynomials. We have this whole mess and that mess. We can find a shortcut to use, or we can just multiply it out. That's up to you. I tend to just multiply it out, but if I were to look for a shortcut, I notice that I have 3p minus 2 twice. I have a plus and a minus. And then I have 5q and 5q. And so this is actually a difference of squares. So we could use that difference of squares formula here. 3p minus 2, well, we can either write that as 3p minus 2 times 3p minus 2 and multiply that out, or we can use that square of a binomial shortcut. I'm just going to multiply this out. 3p times 3p is 9p squared. 3p times negative 2 is negative 6p. Negative 2 times 3p is negative 6p. And negative 2 times negative 2 is positive 4. These are my like terms. So we have 9p squared minus 12p plus 4. Then if we square this, that would be minus, because of the subtraction here. 5 squared is 25, and q squared is q squared. And so this would be the final answer. I can't combine anything else on that because nothing else is like terms. Letter B, x plus y to the third power. Well, we don't have anything for that. So I'm going to write that out. That means x times y times x plus y times x plus y 3 times. Pick 2 of them, multiply them together, get an answer, and then take that answer times this remaining one. So I'm going to start here. I will distribute. X times x is x squared. X times y is xy. X times y is xy. And y times y is y squared. I have my like terms here. 1xy plus 1xy gives us x squared plus 2xy plus y squared. We still have to multiply that by that last x times y. For this one, I think I'm going to use that Punnett square method. And see if that helps me out a little bit. So this is x times x squared, which is x cubed. X times 2xy, 2x squared y. X times y squared, xy squared. Y times x squared is x squared y. Y times 2xy is 2xy squared. Y times y squared is y to the third. Now remember, these are adding in here. You can see the plus signs there. X to the third has no like terms. We're going to write that down. These are like terms, x squared y, x squared y. There's a 1 here, so 1 plus 2 is 3, x squared y. These are like terms, xy squared, xy squared. There's a 1 here, so 2 plus 1 is 3 xy squared. And then y cubed all by itself. This would be our polynomial. It is in standard form. X comes before y in the alphabet, and x goes in order from greatest to least. This is a third degree polynomial, and there are 1, 2, 3, 4 terms, so there is no special name for this. Letter C, 2a plus b to the 4th power. So that means we have 2a plus b 4 times. Now there's any number of ways that you can start this. I'm going to multiply these two together and these two together. And I know I only have to do that once because whatever the product is of the first two will be the same for the product of the second two. So 2a times 2a is 4a squared. 2a times b is 2ab. b times 2a is 2ab. And b times b is b squared. These are my like terms. So this is 4a squared plus 4ab plus b squared. That means the second set of 2 will also be 4a squared plus 4ab plus b squared. So now I just need to multiply these two trinomials together. And I think I'm going to do that using very large Punnett square. Make 4a squared, 4ab, b squared. Four a squared times 4a squared is 16a to the 4th. 4a squared times 4ab is 16a to the 3rd b. 4a squared times b squared is 4a squared b squared. 4ab times 4a squared is 16a to the 3rd b. 4ab times 4ab, 16a squared b squared. 4ab times b squared is 4ab to the 3rd. b squared times 4a squared is 4a squared b squared. b squared times 4ab is 4ab to the 3rd. b squared times b squared is b to the 4th. Again, remembering that these are a bunch of plus signs in here. So we're adding like terms on the inside. Well, 16a to the 4th has no like terms, so we have 16a to the 4th. These are like terms because we have a cubed b and a cubed b. So 16 plus 16 is 32 a cubed b. These three are like terms because they're all a squared b squared. It's all lined up diagonally. Super nice. So 4 plus 16 is 20. 20 plus 4 is 24. A squared b squared. These are like terms. ab cubed, so 4 plus 4 is 8. ab cubed. And then b to the 4th. This is written in standard form. A comes before B in the alphabet. So we have A coming from 4 to 3 to 2 to 1 to nothing. So that's cool. Our degree here is a 4th degree because our largest exponent, which is our first term here, is 4. And there are 1, 2, 3, 4, 5 terms. So there's no special name for this. And that means that this is just called a polynomial. This is where we're going to stop for today in practice. Thanks so much for joining me. Have a good night.